The research question that I decided to explore within my thesis work here at DANM really broke up into three questions. The first question was, how can I help people to understand the vital importance of phytoplankton to our Earth and to our ocean's ecosystems? The second question I asked was, how can I kind of ride the fence between what is an art exhibit and what is a science exhibit, or what is a hybrid of both of those worlds? And a third question that I asked was, how could I create an art and science hybrid out of materials that are biodegradable and ecologically minded, because there's no point in making a project about ocean health if it's all made out of plastic that's going to end up in our oceans and landfills. The piece is Oceanic Scales, and it's what I'm calling now an interactive art and science puzzle. You could call it an exhibit, but it really does ask the viewer to examine the details a little bit more and kind of figure out this puzzle in a similar way that I have figured out the puzzle of the ocean ecosystems. But the physicality of this piece really involves a large installation, an immersive multi-sensory installation that you enter as a viewer or as an observer. And you are confronted by three large, what I call outcroppings. These forms are inspired by rock outcroppings that litter the Central Coast. But I have approached it from what I call kind of a biomimicry model. How can I take inspiration from the form and functions of living systems, but do it within a technological framework? And so you are confronted with a series of kind of pulsing, blinking, rhythmic colored lights, sculptural forms, which I call machinic diatoms. They're mechanically or electronically inspired versions of phytoplankton that encrust these outcropping forms. And then you are also confronted by kind of a central column that invites the viewer to interact. When it comes to interaction, it's been a large discovery for me. A lot of this has been user testing to see how they will respond to this puzzle environment or this interactive environment that we're creating. So I think different people experience it in different ways, and that's why I've tried to give these both a passive and an active way of experiencing the piece. If you want to experience it in a passive form, you can literally just experience what we call its data translation system, where we're tapping into the Monterey Bay Research Institute's Elkhorn Sloan Lobo sensor system and displaying live ocean health through a live temperature, pH, and nitrogen sensor. And we do this through what we call data translation because we're really taking a time lapse of data. All those sensors, they only update every 2 hours, and the average visitor maybe stays 20 minutes. So if we just let it update every 2 hours, no one would ever see the changes. So we decided to push this into a time-lapse mode so that you could see a year's worth of readings of temperature, nitrogen, and pH accelerated into about a 10-minute period. And you can see a whole season cycle that way. And you can also see the correlations between these different readings. So as temperature goes up, so will the pH, or so will the nitrogen, or maybe it's the nitrogen that's causing the shift in the pH with a little bit of help from the temperature. And you can start to draw these connections and see the bigger picture of the larger system. Or you can interact with it and you can play the role of the geoengineer, as we call it, and see what happens when you muck with these levels. If you try to go in there in this controlling way and turn up the temperature or turn down the pH or turn up the nitrogen and see what happens. And hopefully people will walk away with a sense that, short-term technological fixes aren't always the best way to address these larger system problems. And they can also maybe get a sense of their direct impact on these systems and how, small shifts can make large impacts in different ways.